The following is the video solution from JSDT Solutions. Question 7 says, in the diagram below, the graph of f of x is equal to -2 sine x is drawn for the interval where x is an element of -180 degrees to 180 degrees. And here is our graph, okay? And 7.1 says, on the grid provided in the answer book, draw the graph of g of x is equal to cos x minus 60 degrees for where x is an element of -180 to 180 degrees. Clearly show all intercepts with the axes. So this would be the x and y intercepts and the turning points of the graph. Okay, so this is the graph that we need to draw. For you to be able to sketch this graph, you need to understand what the original cos graph looks like, and then understand what exactly is being applied here. We have an x minus 60 degrees. This shift, whatever it is, it's affecting the x, okay? It's directly saying x minus 60 degrees. Now, if you subtract from the x, then this means that this is a shift to the right. If you add to the x, this is a shift to the left. So this means that this graph is shifting 60 degrees to the right. Okay, so it's just the natural cos graph shifting 60 degrees to the right. You know, the shape of the cos graph looks like this. Okay, so in our diagram, what that would look like, and you could do this part with a pencil first, would be like this. Notice that this goes from 0 degrees to 180 degrees. So it's not going to show that full shape. It's going to show half of it. It's going to show this part from 0 degrees to 180 degrees, which is over here. Okay, so cut it in half, and that's 180 degrees over there. So it needs to have that shape. So let's just do that first so that we can just understand what the shift would look like. So understanding the major point, it's going to have at 0 degrees, it will be equal to 1. This is the cos of x graph, right? And then at 90 degrees, it's equal to 0. And then at 180 degrees, it is equal to -1. So it looks like that, just, curved, and then it reaches there. Okay, so something like that. And then this side would do the exact same thing. It's also going from 0 to -180 degrees. So it will look exactly the same as well. It will do that. And then like that. Okay, notice that the minimum is at -1, not -2, like that the graph we have. Okay, so if this is what cos of x looks like, then what would cos of x minus 60 degrees look like? This is going to be shifted to the right. So instead of having a y value of 1 at 0 degrees, this y value of 1 will appear at 60 degrees, okay, 60 degrees later. So you're really just taking this graph and you're shifting it 60 degrees to the right. They already cut these into 3 and you see we end at 90. So that is going to be 30, 60, 90. So at 60 degrees over here, this graph ends up here. So now we can just start writing down what the real graph looks like. The shift is going to look like that. That maximum will be there. And then this is another important point, an x-intercept. Where will this x-intercept appear? It's going to appear 60 degrees to the right. So 90 plus 60 is 150 degrees. So it's going to appear at 150 degrees. That is 90, it's counting in threes, okay? So 90, 120, 150. And that's where that appears. Okay, and so on. And then another important point would be this here, where it's equal to -1, because that is a turning point. And that happened at -180 degrees. It's going to now happen 60 degrees ahead of this. So you're just moving 2 places, okay? 30 and then 60. So it just appears here at -120 degrees. And then you can just join your graph. It's going to do that, curve up and then down. Okay, and then at this point, you can just erase that one that helped to find what this graph looks like, and then just complete it, because this is that new turning point that we have over here. You know that this is just going to curve upwards, and it won't, of course, reach the -180 degrees yet. And it will cut off at this point since we don't go anything beyond that. Okay, so let's just put down those important points. We know now that that is -120 degrees and -1. Okay, this over here is negative 30 degrees, which we already have there. We don't have to overthink that. And then over here, this maximum, this turning point over here is going to be at 60 degrees and a y value of 1. And we have 150 there. Okay, are there any other important points that we should note down? Okay, there is one more. Since these are turning points and x-intercepts that we have, okay, negative 30 degrees and positive 150 degrees, then we should probably also put down this y-intercept over here. To understand what exactly this would be, just think about it like this. If it is at 0 degrees, remember that this graph was shifted 60 degrees to the right. So this solution, right, this y value, where was it initially before the shift? It would have appeared 60 degrees to the left. So for us to find out what exactly this y value is, find out what cos of negative 60 degrees is, since this value shifted to the right to end up at 0 degrees. That's why we have this over here, 0 degrees, and that answer. So what is cos negative 60 degrees? That's what we'll need to find out. You could use a calculator or use reductions, because negative 60 degrees would simply be equal to a half. Okay, if you use the reductions, you'll see that it would be that. So we know what that is now. That is now 0 degrees and a half. 0 degrees and a half, but we don't have to say 0 because we can see it passes 0. It's the y-axis. So simply just say a half. And that may be helpful along the line with the questions. And that is our answer. That is what the graph of G would look like. Question 7.2 says, write down the period of f of 3x. So do you notice that this is normally supposed to say f of x, but they've replaced x with 3x. So it just means that in the equation of f, replace x with 3x. If we did that, then we have a 3 now in front of the x, which is going to affect the period. To find the new period, you can take the original period. Looking at the graph of f, it is a sine graph. So the original period of a sine graph is 360 degrees because it takes the sine graph 360 degrees to complete one cycle. And then this cycle, again, this pattern would repeat itself 360 degrees later and even before that. So we'll take the old period, 360 degrees, and we'll divide it by the coefficient of x. And so our period is equal to 120 degrees. This graph is going to complete one cycle in 120 degrees, which means it's going to be more narrow. Okay, moving on to the next question. Question 7.3 says, use the graphs to determine the value of x in the interval where x is an element of negative 180 degrees to 180 degrees, for which f of x minus g of x is equal to 1. Here, you really just need to think about combinations where you say a y value of f minus a y value of g, and then they give you 1. So these can be numbers like 2 minus 1 or 1 minus 0. These all give 1. So if we can find places where the graph of f and the graph of g are equal to numbers like this, this could work. Okay, so you could inspect the graphs and just see where this happens. Another way to think about this is we could rewrite this equation as f of x is equal to and transpose g of x. So it's now positive g of x plus 1, meaning look for places where f of x would be exactly equal to where they would intersect if you took g of x and you shifted it up by 1 unit. That's another way that we could think about. So, okay, if we took the graph of g, I'm just taking half of it, and we shifted up by 1 unit, see the important places, like over here it's at 0. If you shift it up by 1 unit, it's actually going to intersect perfectly with the graph of f. So at that point over there where x is equal to negative 30 degrees, that's where that solution would be. So if we put it back there, you see that here the graph of f has a y value of 1. And if you said f of x, right, that y value of 1 minus g of x, this over here has a y value of 0. You see that 1 minus 0 is 1. Okay, so there we go. It will happen here at negative 30 degrees. And if we wanted to see whether there were any more solutions, we could still think about it as shifting that up. If you shifted everything on G up by 1 unit, would you have any other place where they intersect? And yeah, it actually does intersect somewhere else. And I don't even think this was intended to happen. But what we can do is just go with the x equals negative 30 degrees because this question was specifically a 1-mark question. Okay, so we can just tell them this is where x is equal to negative 30 degrees. And that is our answer. Moving on to the next question. Question 7.4 says, write down the range of k if k of x is equal to a half g of x plus 1. Okay, so it's the graph of g of x. And with the graph of g of x, you see that there was no upwards or downward shift. So it's just really this graph. We don't have to over-consider that x minus 60 degrees because that affects the x values, not the y values. At the end of the day, this graph is still a cos graph. So the highest that the normal cos graph, the natural cos graph, cos x, would reach would be 1. Now, since this one has a coefficient of a half, okay, it's just going to be a half cos x minus 60 degrees. It means that the highest it'll reach would be a half when we just apply that a half. Okay, so it still looks like the image that we have, but we don't have to overthink the way that looks. So it just goes like that. We can just draw that there, of course, for reference sake. Okay, so something like that. And then I'm just replicating it over here. So now the highest that it's reaching is a half when we just apply that half. And then the lowest would be at negative a half. But then this graph is shifted up by 1 unit. So now what is the minimum going to be? Where will that y value of the minimum be? If it shifts up by a half, from negative a half, just add 1. That's going to be at positive a half. So it shifts up. We're just going to have to shift this graph a bit lower. It's going to just simply look like this. So from where it is, it's shifting up by 1. And now the minimum, the y value is at a half. And the maximum's y value would be at, this maximum was at a half. You're just going to add 1 to that. So plus 1 would be at 1.5, which is 3 over 2. So that's 3 over 2. So it means that it reaches a maximum of 3 over 2 and a minimum of a half. That's what it's going to look like. Okay, so the range would be all the possible y values of this graph. Since it has every single y value, but it does not go beyond or below a half and does not go above 3 over 2, then the y values would look like this. So the range should be y is greater than or equal to 1 over 2, but less than or equal to 3 over 2. And that will be our answer. So we can, of course, write this as a set. So in set builder notation, which would be y is an element of, and we're going from 1 over 2 as an included y value all the way to 3 over 2 as an included y value, and that's why we're using square brackets. So you can write it like this or like that, and that'll be perfectly fine. Okay, so that is the answer. That will be the range of k. And that is it for question 7.